Now, the problem with biodiversity data is that traditionally and still up to date, there are people that needs to collect them. So still the sensors and so aren't good enough that we can get all the biodiversity data out there, which means they're spatially biased. There are areas in Europe where you can find better biodiversity data and other where you have less biodiversity data. They are biased in time. Yeah? There are better recent data than previous data, and it's very difficult to get some proper baseline data. Then they are taxonomically biased because, many people love birds, flowers, butterflies, and they're pretty well mapped across Europe. But other taxa are not as well mapped. And then there's these hierarchical nested designs which make it really difficult to store these data. Probably a dozen of different models at different scales, different realms, different taxonomic units that would answer the questions on what are the trends that were observed in the past, what might be possible future trends, what might be the distribution of species under future conditions, under scenario conditions in the future, what are the inventories of Natura 2000 sites or so, and the stakeholders can individually ask the questions and then go to the virtual research environments and, let's say, tweak the models or tell the models what they would like to do and interact with the biodiversity data themselves. So probably this will provide the best suite of biodiversity data and the most easily accessible model outputs for policymakers and decision makers, which they can then use and query in almost real time what is the state of biodiversity and what might be the impact of specific decisions, management options, interferences on the state of biodiversity and on the dynamics of biodiversity. So we hope that in almost real time, policymakers and decision makers can see the impacts of what they intend to do.